After discussing into details the electrolysis of sodium chloride solution, where we have realized that in a case of concentrated solution, chlorine gas and hydrogen gas is produced. But when we have dilute sodium chloride, then there is evolution of oxygen gas at the anode and still hydrogen gas at the cathode. Today, let's talk about electrolysis of copper 2 sulphate solution. We want to look at what will happen at the anode again and what happens at the cathode. Still, positive ions migrate to the cathode as negative ions migrating to the anode. So this is the setup for the electrolysis of copper 2 sulphate solution with copper electrodes. So we have in the diagram sulfate ions and hydroxyl ions migrating to the anode as copper ions and hydrogen ions migrating to the cathode. What is the equation at the cathode? So here we have copper 2 ions and hydrogen ions migrating here. Copper is lower than hydrogen in the electrochemical series. Therefore, it is discharged in preference to hydrogen. This is discharged. Therefore, the equation will be copper 2 ions gaining 2 electrons to form copper solid. That is the equation at the cathode. At the anode, we have hydroxyl ion and sulfate ion migrating here, and hydroxyl ions is discharged in preference to sulfate ion because of the position in the electrochemical series. So we'll have hydroxyl ion undergoing oxidation to give us water, oxygen gas, and 4 moles of electrons. So that is 4 of that, and that is the equation at the anode. It is clear from the illustration that the solution will turn into sulfuric 6 acid because there is hydrogen ions left that will combine with the sulfate ion left in the solution, and that will lead to formation of sulfuric 6 acid. And that is all about the electrolysis of copper 2 sulfate solution when we use graphite or platinum electrodes, or the one that is known as carbon electrodes. I want us to look at the electrolysis of the same copper 2 sulfate using copper electrodes. There is a factor that we considered known as nature of electrodes, and this is the illustration that will tell more story about the nature of electrodes. So now, same electrolysis of the same salt, electrolysis of copper 2 sulfate using copper electrodes. This is what we want to use to explain the nature of electrons. The ions present are ions that are present include copper 2 ions, sulfate ion, sulfate ion, hydrogen ion, and hydroxyl ion. At the cathode, we have copper 2 ions and hydrogen ions migrating to the cathode. So again, here the copper 2 ions are discharged and a brown deposit of copper is seen on the cathode. So we have these copper ions discharged. So that will be copper ion reacting with 2 moles of electrons to form the copper solid. And that is the reduction process after the discharge of the copper 2 ions. As the experiment proceeds, copper ions are removed from the solution, and we would expect the solution to become lighter in color. This apparently is not the case, because we normally say that once what is responsible for the color is discharged, the copper 2 ions is what is responsible for the blue color, of which we would assume that once it is discharged, then the blue color would disappear or would fade off. However, this does not happen, meaning that copper is discharged is constantly being replaced by the dissolution of copper anode. So at the anode, the copper 2 ions dissolve in the copper dissolve into the solution. So the anode will have copper, anode is oxidation, copper solid, that is the electrode, dissolve to give copper ions plus 2 moles of electrons. The loss of mass of the anode is equal to the gain of mass of the cathode, and the intensity of the solution stays the same. This is the basis of the purification of copper. That is to say, when you try to purify copper, the first thing that happens is that the impure copper go into the solutions, and then after forming the ions, it is the ions that get reduced at the cathode, leaving the anode mud, and once they migrate to the cathode, they get reduced to form copper solid, which is pure. That is all about electrolysis of copper to sulphate solution.